Welcome to Study Loop.
In this problem, we have been given that there's a car and the car's speed is increased by 50%. Then we need to figure out the factor by which the braking distance will be increased. So here let's consider the speed of the car initially with which it's moving as v. And as we're talking about the braking distance, so in that case, all other parameters here are assumed to be constant. So there will be a constant deceleration. So here we observe that finally the speed of the car will drop to zero. So we apply the kinematic equation 2as is equal to v square minus u square. And s here is the displacement, which is the braking distance, of course. So v is the final velocity that will be zero. And we can say that the braking distance will be minus u square by 2 times of acceleration. And here we are actually retarding the motion. So the braking distance will come out to be a positive quantity, and it is dependent on the square of the initial speed with which the car is moving. So here in this problem, we have been given that the speed is increased by 50%. That means if initially the speed is v, its speed is made 1.5 times v. That's the increased speed, 50%. So here, as the braking distance is dependent on the square of the speed. So if it is increased by 50%, then we can say the new braking distance will become 1.5 square times the original speed. So here we observe that the braking distance even it becomes 2.25 times the original braking distance if the speed is increased by a factor of 50%.